When you gaze at the night sky, what do you perceive? Is it merely a dark expanse dotted with tiny lights, or is there something more profound? Thousands of stars twinkle back, each one a luminous beacon from a distant era. Each star is a distant sun, potentially with its own planets engaged in a delicate cosmic dance. Our universe is vast and enigmatic, stretching far beyond the bounds of our imagination. It contains billions of galaxies, each with billions of stars forming a complex web of cosmic wonders. It's a realm of stunning beauty and complexity, where nebulae glow with vibrant colors and galaxies swirl in majestic patterns. Humanity has always been captivated by the cosmos, gazing up with wonder and curiosity. Ancient civilizations crafted stories about the stars, weaving myths and legends that connected them to the heavens. They created constellations from star patterns, seeing heroes, gods, and creatures in the night sky. Today we explore the universe with powerful telescopes, peering deeper into the cosmos than ever before. We send probes to distant planets, seeking to uncover the secrets of our solar system and beyond. We are driven by a profound desire to understand our place in the cosmos, to know where we come from and where we are headed. One question in particular captivates our imagination. Where did it all begin? How did this grand tapestry of stars and galaxies come into existence? How did this vast and intricate universe come to be? What forces shaped the cosmos into what we see today? The answer, as far as we know, lies in an event called the Big Bang, a moment of unimaginable energy and creation. This event wasn't an explosion in the traditional sense, it was the rapid expansion of space and time itself, a cosmic birth that set everything in motion. It created the galaxies, stars, and planets we see today. It marked the beginning of everything we know and love, the start of a journey that continues to unfold. But what existed before this momentous event? What lay in the void before the birth of the universe? That's a question that continues to puzzle scientists and dreamers alike. It's a mystery that drives us to keep exploring, to keep looking up at the night sky in wonder. Imagine the universe concentrated into a tiny point. This point, often referred to as a singularity, contained all the mass and energy of everything we know today. It was incredibly hot and dense, with temperatures and pressures beyond our current understanding. Then, about 13.8 billion years ago, it happened, the Big Bang. This wasn't just an explosion in space, it was the rapid expansion of space itself. Space began to expand, stretching and growing at an unimaginable rate. It wasn't an explosion outward, but rather an expansion of space itself, causing everything within it to move apart. Think of a balloon with dots on it. As the balloon inflates, the dots move farther apart from each other. This is a simple analogy to help us visualize the expansion of the universe, similar to how galaxies moved away from each other as space itself grew. As the universe expanded, it also began to cool down. This cooling process was crucial for the formation of matter. It allowed matter to form, starting with the simplest particles. Tiny particles came together to create atoms, the building blocks of everything we see around us today. Gravity played a key role in this process, pulling these atoms together to form stars and galaxies over billions of years. The Big Bang theory is supported by a wealth of evidence, from the movement of galaxies to the cosmic microwave background radiation. We see galaxies moving apart from each other, a clear indication of the universe's ongoing expansion. This shows that the universe is still expanding, continuing the process that began with the Big Bang. We detect faint radiation left over from the Big Bang, a remnant of the universe's fiery birth. This is known as the cosmic microwave background radiation, a snapshot of the early universe. The Big Bang model elegantly explains many of the universe's observed features, from the distribution of galaxies to the abundance of light elements. However, it leaves some big questions unanswered. For instance, what caused the Big Bang in the first place? Was it a random event, or is there a deeper reason behind it? What, if anything, existed before it? Was there a void, another universe, or something entirely different? These are questions that continue to push the boundaries of our understanding, driving scientists to explore the deepest mysteries of our universe. The Big Bang theory describes the evolution of the universe, but it doesn't tell us what, if anything, existed beforehand. The very concept of before the Big Bang is problematic, as time as we understand it began with the Big Bang. Asking what came before is like asking what's north of the North Pole. It's a question that seems to defy logic. Yet it's a question that humans can't help but ask. It's in our nature to seek answers and push beyond the boundaries of the known. Could there have been something else before the Big Bang? Some physicists believe that our universe is just one of many. They propose the existence of a multiverse, a vast collection of universes. Others suggest that the universe goes through cycles of expansion and contraction. In this view, the Big Bang may have been preceded by a big crunch. These are just some of the mind-boggling ideas that scientists are exploring. The truth is, we don't yet have the answers to these profound questions. But that's part of what makes cosmology so exciting. Echoes of the primordial universe provide evidence for the Big Bang. While the idea of a beginning to everything might seem strange, there's strong evidence to support the Big Bang theory. This theory isn't just a wild guess or a fanciful story, it's grounded in solid scientific observations and rigorous measurements that have been collected over decades. It's a well-supported scientific theory that explains many of the phenomena we observe in the universe today. Scientists have used advanced technology and sophisticated instruments to gather data that supports the Big Bang theory. One crucial piece of evidence is the cosmic microwave background radiation. This radiation is a faint glow that fills the universe and is a remnant from the early stages of the universe. It's like a snapshot of the universe when it was just a few 100,000 years old. By studying this radiation, scientists can learn a great deal about the conditions of the early universe. They can infer the temperature, density, and even the composition of the universe at that time. Another key piece of evidence is the abundance of light elements, like hydrogen and helium, which were formed in the first few minutes after the Big Bang. The Big Bang theory predicts the precise ratios of these elements that should have been created in the early universe. Amazingly, these predictions match up perfectly with our observations. The expansion of the universe is further evidence, first observed by Edwin Hubble in the 1920s. He noticed that distant galaxies are moving away from us. This is known as the redshift effect, where the light from these galaxies is stretched to longer, redder wavelengths as they move away. The farther away a galaxy is, the faster it's receding. This relationship, known as Hubble's law, provides strong evidence for the Big Bang theory. This observation supports the idea that the universe began from a single point and has been expanding ever since. The Big Bang theory not only explains the origin of the universe but also its ongoing expansion, providing a comprehensive picture of the cosmos from its earliest moments to its current state. Peering through time, telescopes as time machines. How do we see the past? It might sound impossible, but that's precisely what telescopes allow us to do. Light travels at a finite speed, and the light from distant objects takes time to reach us. When we look at a star that's 100 light-years away, we're seeing it as it was 100 years ago. Powerful telescopes like the Hubble Space Telescope act like time machines, allowing us to peer billions of years into the past. By studying these distant objects, we can piece together the history of the universe. These technological marvels constantly push the boundaries of our knowledge, allowing us to see fainter and more distant objects than ever before. They give us a glimpse into the universe's infancy, closer to the Big Bang. Each new discovery brings us closer to understanding our cosmic origins. Beyond the Big Bang, the multiverse and other ideas. While the Big Bang theory is our best explanation for the universe's origin, it's not the end of the story. It raises many new questions and possibilities. Some physicists believe that our universe might not be the only one. This idea, known as the multiverse, proposes that there could be an infinite number of universes, each with its own set of physical laws and constants. Imagine a vast cosmic landscape where universes bubble up like foam in a bathtub. Each bubble represents a different universe with its own unique properties. Another intriguing idea is that the universe goes through cycles of expansion and contraction. Perhaps the Big Bang wasn't the beginning but rather a transition from a previous phase of the universe. This cyclical model suggests that the universe could expand and contract over incredibly long periods. These ideas might sound like science fiction, but they are active areas of research. They demonstrate the boundless capacity of the human mind to explore the unknown.